Now we shall see about economic batch quantity. The concept of economic batch quantity is similar to economic ordering quantity. The economic batch quantity is applicable to the production of finished goods, whereas economic ordering quantity is applicable for the purchase of the raw materials, stores and spare parts. Economic batch quantity considers the following. The first one is the annual demand of a particular item of article. The next one is the setup cost per piece. Third one is the cost of storage. Then fourth one is the rate of interest on capital invested. Then the fifth one is the manufacturing cost of an item. So economic batch quantity is concerned with the annual demand, setup cost, cost of storage, rate of interest and also the manufacturing cost. Now we shall see about the assumptions of economic batch size. The annual carrying cost can be accurately estimated and known as that of the EOQ. Setup cost can be accurately estimated and it is fixed. It does not change with the lot size. The annual demand can be estimated and is linearly consumed by customers. There is no safety stock. As a consequence of second assumption, namely the setup cost being fixed, no stockout cost will occur. There are no quantity discounts. The rate of production exceeds the rate of usage by customers during the production period. This assumption requires that for the period of a production run, the amount produced per hour, per day or per week is greater than the demand during the same period of time. All production not used to satisfy the demand is placed in inventory. This assumption requires that excess production, that is the production minus the demand, has to be placed in inventory. Thus, the increase in inventory is not instantaneous, but it is gradual. If there are frequent changes in the setup of a machine, the setup cost will be very high. If the batch is larger in quantity, the storage cost will be very high. Setup cost should not be high and carrying cost per unit per annum should be the minimum at which economic batch quantity is decided upon. The total of the two costs should be economical. The formula will be EBQ is equal to square root of 2AS divided by C, where A is the annual demand, S is the setup cost and C is the carrying cost of 1 unit per annum. In EBQ formula, A is the annual demand, S is the setup cost and C is the carrying cost of 1 unit per annum. Therefore, EBQ is equal to square root of 2AS divided by C. The EOQ formula may also be modified to account for the fact that only a portion of the production goes into the inventory and the other portion is sold. The production rate P is of course not instantaneous and must be greater than or equal to the rate D, namely the demand. The ratio D by P, that is the demand divided by the production rate, represents the proportion of production run that goes into the inventory. If we take into account the decreased cost of this reduced level of inventory, the economic run length ERL or batch quantity in number of units per production setup would be. ERL, economic run length, is equal to square root of 2 into setup cost into annual demand divided by carrying cost into 1 minus annual demand divided by annual production. When the demand rate is just equals the production rate, there is no carrying cost and the run length is continuous. Alternatively, economic batch quantity can be arrived at with the help of the tables by trial and error method. It can also be solved graphically as in case of economic ordering quantity. Now we shall see what is the meaning of a setting up time. The word setting up refers to the preparation of the piece of equipment for an operation or for the next operation. Setting up cost or setup cost means the cost of setting up the equipment, especially in batch production. It is an important factor in decisions concerning the batch size and economies of scale. Setting up time refers to the time taken to set up a machine or to changing it from making one product to another. Setup time is made up of 4 basic components which apply to all types of machineries, and they are as follows. Preparation and finishing, getting the parts, fixtures, tools ready and delivering them to the machine, and the reverse of the process, taking the old ones away together with necessary clearing or maintenance. This component represents about 30% of the setup time. Next is mounting and removal of tooling and fitting. This component represents about 5% of the setting up time. Then measuring, calibrating and adjustment. This is done to ensure the correct positioning, the speed, the temperature or other conditions are ensured. This component accounts for around 15% of the time. So, measuring, calibrating and adjustment has to ensure the positioning, the temperature and the speed. Trial runs and adjustment are made to ensure the machine is set up correctly. This accounts for around 50% of the setting up time. Clearly, better the adjustment, less is the time required at this stage. What are the steps to reduce the setup time? Reducing the setup times is very crucial in just-in-time production since it offers increases in flexibility, shorter lead times and reduced inventories. It also offers firms a chance to compete effectively in market characterized by demands for greater product variety or more rapid product innovation. To reduce this setup time, we have to select the machine setup and the machine has to reduce the setting up time. Appoint a team consisting of 3 to 4 setup personnel and a facilitator or a team leader backed by production, industrial and maintenance engineers. Then video tape details of the setting up should be given. Analyze the setup procedure and classify the activity into internal and external activities. Internal activity represents the work that can be performed when the equipment is stopped, whereas the external activity represents the work that can be done when the equipment is running. Take for example, the typical external setup activities include the preparation of the dies and fixtures, and the actual movement of dies in and out of the stores and to and from the machine in question. Typical internal task is attaching or dispatching the dies, adjustments and testing. It is estimated between 30 to 50% of the total setup time. And this 30 to 50% can be saved by doing the external setup rather than including these operations as a part of the internal setup. Examine the external activities critically to decide when to perform them in order to reduce the downtime. External activities such as clearing, setting aside the parts and the fixtures used in the previous job, or bringing the parts of fixtures for the next job, obtaining the tools and gauges from the tool room, locating the material handler, locating and selecting the bolts of appropriate length, sharpening the blunt tools at the time of setup, conducting the calculations for the speeds and the gear sections, etc. can be done either ahead of the setup activity and whereas after the machine setup activities. Reduce the internal setup time by doing more of the setup externally. This can be done, for example, through the use of preset dies or special easy fixtures holding the new dies. The external setup time can themselves be reduced by color coding, special transport equipment, etc. which are all designed to minimize the time taken for moving and finding. The internal setup time can also be reduced by simplifying the adjustments, simplifying the attachments, devoting extra resources to them at the critical time, etc. Another important way of reducing the internal setup time is parallel operations, where extra assistance is provided at the critical time of changeover and the time is reduced by several people working in parallel. This will not only improve the things by having extra pairs of hands, but it cuts the time out which a single operator would spend moving around the fetching, carrying and fitting. Reduce the total time for both external and internal setup. Implicit in this is the concept of continuous improvement, of constantly monitoring, analyzing and developing the new attacks on the problem. Changing over the setup is thus a precision, team-based activity in which everything is to hand, special purpose tools and fixtures are used, and everyone knows what he or she has to do. A very close and effective analogy can be seen in motor car racing, where a car makes a pit stop for tires to be changed. This is accomplished in few seconds as a result of very similar process. We shall see some of the problems in EBQ and EOQ. First, we shall start with the economic ordering quantity, EOQ. First problem. The following information is given by the company. Purchase department expenses is 2 lakhs. Stores personnel expenses is 2 lakhs. Obsolescence is 60,000. Higher charges of warehouse 1,40,000. Collection cost 40,000. Receiving cost 35,000. Inspection cost 50,000. Material handling in the stores 1,60,000. Bills payment expenses 75,000. Interest charges 14.5%. Insurance charges 2%. The company places 5,000 orders per year and has an average total of rupees 100 lakhs. calculate the total ordering cost and the inventory carrying cost. First of all, we have to identify the ordering cost and the carrying cost. The purchase department expenses, collection cost, receiving cost, inspection cost and bill payment expenses. All these items are said to be the ordering cost. Carrying cost is stores personnel expenses, risk of obsolescence, higher charges to warehouses and materials handling in the insurance stores. Apart from this, the insurance and the interest should also be included in carrying cost. Now we shall calculate the total ordering cost. Purchase department expenses is 2 lakhs. Collection cost is 40,000. Receiving cost is 35,000. Inspection cost is 50,000. Bill payment expenses is 75,000. So total amount is 4 lakh rupees divided by number of orders per year. It is given in the problem as 5,000 orders per year. So 4 lakhs divided by 5,000, it will give you rupees 80. So 80 rupees is the cost per order. Now the carrying cost. Stores personnel expenses is 2 lakhs. Obsolescence is 60,000. Higher charges to warehouses is 1 lakh 40. Material handling in the stores is 1 lakh 60. Insurance is 2% on 100 lakhs, average total cost. Interest, it is 14.5% on 2 lakhs. So it will be insurance 2 lakhs, interest is 14 lakhs and 50,000. Totally we will get 22 lakhs and 10,000. Now the inventory carrying cost will be calculated as a proportion of inventory cost to the average inventory. So 22 lakhs 10,000 are divided by 1 crore into 100, you get 22.1%. The second problem. From the following data obtained in respect of an item of store, calculate the economic ordering quantity for the item. Total annual consumption is 12,000 units. Unit purchase price is 1 rupee. Ordering cost is 75 rupees per order. Then the cost of carrying inventory is 20% per annum. Now the EOQ formula is 2AO divided by I. Square root of 2 into 75 ordering cost into consumption units is 12,000 divided by 20% is the carrying cost per annum. It is 20% of 1 rupee. We will get 3,000 units. If 3,000 units are ordered, the cost will be 4 orders. Say here we will get 12,000 per annum. So divided by 3,000 units, we will get 4 orders. So 4 orders into 75 rupees per order, it comes to 300. Carrying cost should be calculated always on the average inventory, 2 by 2. What is the order now? 3,000. 3,000 by 2 will get 1,500 units. So 1,500 units into 1 into 20%, 1 by 5. That will be 300. So total inventory cost is 300 plus 300, that is 600. The third one. XYZ Limited consumes 4,000 units of a particular item every year. The cost per order has been ascertained to be rupees 240. The price of the unit is rupees 10. The inventory carrying cost of the company are 30%. Determine EOQ. The formula will be again 2AO divided by I. Square root of 2AO divided by I. Now square root of 2 into 4000 units into 240 rupees per unit per order divided by 30% of this 10 rupees. We will get 800 units. Therefore, the EOQ is 800 units. The company is going to order for 800 units. So, the annual consumption is 400. When we are going to order 800 units per order, number of orders will be 5. Now, this can be verified by framing a table again. We will have 4 different plants or 4 different orders, wherein we will start with the 400 units as order size, 500 units, 800 units and 1000 units. We will have 4 different orders. We assume 400, 500, 800 and 1000. The number of orders is 4000 by 400, 10 orders. 4000 by 500, 8 orders. Then 4000 by 800, 5 orders. We will get for 500 units, 4000 by 500, 8 orders. For 800 units, 4000 by 800, 5 orders. Then 4000 annual consumption, order size is 1000, so we will get 4 orders. Now ordering cost is 240 per order. Into 10 orders, we will get 2400. Into 8 orders, 1920. Then into 5 orders, 1200. Into 4 orders, it is 960. Average inventory is the order size divided by 2. 400 by 2, 200. 500 by 2, 250. 800 by 2, 400. 1000 by 2, 500. Now the carrying cost is 30% of the average inventory. That is 3 rupees. 3 rupees into 200, you get 600. See, 10 rupees into 30%, we will get 3 rupees. 3 into 200, 600. 3 into 250, 750. 3 into 400, 1200. 3 into 500, 1500. So carrying cost will be calculated on average inventory. What is the total cost now? Cost of ordering plus cost of carrying. For the first plant, it is 2400 plus the 600, 3000. Then 1920 plus 750, you get 2670. This is for plant B. Then for C, 1200 plus 1200, 2400. For D, 960 plus 1500, 2460. Now the total cost is minimum for the plant D or the order C. So when we have the order C, 2400 is the minimum. So 800 units is said to be the EOQ. Slowly the total cost declines. 3000, 2670, 2400 and 2460. Then it increases after C, after the third one. When you see the ordering cost decreases as the number of orders decreases. When we have the number of orders decreasing, the order size increases. As the order size increases, the carrying cost also increases. So I will put it in a nutshell again. Number of orders decreases, the order size increases. As the number of order decreases, the ordering cost decreases. As the order size increases, the carrying cost increases. So we have a midpoint wherein the total cost is minimum. It is the plant C or the order C, 2400. Till C, the total cost decreases, and after that the total cost increases. So this is the place where the total cost is minimum and we have a strikeout of the ordering cost and the carrying cost. As we said earlier, the ordering cost and carrying cost will be almost equal. See 1200 and 1200. So in practice, however, EOQ may not be the only criterion to be considered while deciding the quantity to be purchased. Under certain circumstances, the ordering quantity may be different, either more or less than the EOQ. Say for example, in case of items for which there is a restrictive import policy by the government, then the nature of the item also influences the ordering quantity. If the item available only during a particular season of the year, but it is consumed throughout the year, more quantity has to be ordered. If there are transport difficulties, the order quantity may be more than the EOQ. Then availability of the funds also influences the quantity to be ordered. In order to get a bulk discounts, more quantity may be ordered. Bulk discounts may be in the form of quantity discounts. Sometimes a question may arise as to whether it is desirable to order more than the EOQ to obtain the benefit of bulk discounts. If it is so, the total ordering cost will come down, but the carrying cost will go up. Therefore, the combined effect of ordering cost and the carrying cost on one hand to be compared with the savings arising out of the bulk discounts on the another. The final decision on this issue will depend naturally upon the net effect of the increase in the inventory cost and the savings due to the bulk discounts. And this we can learn with the following illustration. A firm is able to obtain quantity discounts on its order of materials as follows. If the materials are to be ordered in quantities less than 250, the price is 6. If it is between 250 and 800, the price is 5.90. If it is 800 and above but less than 2000, the price is 5.80. If it is 2000 and above and less than 4000, the price is 5.70. And if it is 4000 and above, the price is 5.6. The annual demand for the material is 4000 units. The stock holding cost is 20% of the material cost per annum, and the delivery cost per order is 6 rupees. Now we have to calculate what is the best quantity to order in the case of the discounts. First, it is assumed that the order will be for 4000 units and we don't have any discounts given by the supplier. EOQ is square root of 2 into 4000 into 6 divided by 5.6 into 20%. That is, we are getting only 5.6 as the lowest rate because we are going to have a single purchase as 4000. We will get 5.6 as the price. So into 20% we will get 207 units. So when the management is going to have an order for 4000 units and the request for staggering 207 units and it gets the materials only at 5.6 per unit. Now we shall see under a tabular method which batch is beneficial. We shall have the ordering quantity as or ordering size as 200, 250, 800, 2000 and 4000. As per the problem, the price per unit will be 6, 5.9, 5.8, 5.7 and 5.6. The cost of purchase will be 4000 into 6, that is 24,000. 4000 into 5.9, 23,600. 4000 into 5.8, 23,200. 4000 into 5.7, 22,800. 4000 into 5.6, 22,400. Now the cost of holding 200 by 2, that is the average inventory, into 20% into 6 rupees, that is 120. The same way for the 250, it will come to 147.50. For 800 units, 464. Then for 2000 units, 1140. Then 4000 units, 2240. Now the ordering cost will be 4000 by 200 into 6 will get 120. The same way for the second one, 96 rupees, then 30 rupees, 12 rupees and 6 rupees. The total cost is now 24,240 when it is ordered as 200, 23 rupees, 23,843 rupees for 250 units, 23,694 for 800 units, 23,952 for 2000 units, and 24,646 for 4000 units. See to it, the total cost slowly decreases till 800 units and it increases. So this 800 units is said to be the best ordering quantity, and again we can find that the cost of holding slowly increases as and when the order size increases, and we will have the ordering cost as decreasing when the order size increases. So this is the problem which is related to the quantity discounts and finding out the EOQ. We shall see the other problems in EOQ. The following information is available about ABC company which manufactures electric fans. The company has an average total inventory of rupees 100 lakhs and places 4,000 orders every year. Purchase department expenses rupees 2 lakhs. Stores, warehouses, personnel salary 2 lakhs. Obsolescence and spoilage is 60,000. Floor space charge related to stores activities 1,40,000. Warehousing activities include the following: cost of collecting material 40,000, cost of receiving materials 35,000, cost of inspection 50,000, cost of material handling for warehousing activities 1,50,000, cost of bill payment 75,000, interest 12.5%, insurance charges 2%. The company wants to buy a certain component whose price is rupees 12 each and the annual requirement is 17,280 numbers. Calculate the cost of placing an order, cost of carrying the inventory at 12.5% of inventory and the EOQ. First we will calculate the cost. Procurement cost is 2 lakhs, purchase department expenses is 2 lakhs, cost of collecting materials is 40,000, cost of receiving materials is 35,000, cost of inspection 50,000, cost of bill payment 75,000. So totally it comes to 6 lakh rupees. This is the total ordering cost. Number of orders placed is 4,000. Then cost per order is 6 lakhs divided by 4,000. It comes to rupees 150 per order. Now we calculate the carrying cost. Warehouse personnel salary as 2 lakhs. Obsolescence and spoilage 60,000. Floor space charges 1,40,000. Interest charges 12.5% on average inventory of rupees 100 each. It is 12,50,000. Material handling 1,50,000. Insurance charges at 2% on average inventory 2 lakhs. So 20 lakhs is said to be the carrying cost. Inventory carrying cost will be calculated as follows. 20 lakhs divided by 100 lakhs into 100 will get 20%. See, now the price of the component is 12 rupees. Annual requirement is 17,280 given in the problem. Now EOQ is equal to square root of 2AO divided by I. So 2 into 17 to 80 into 100 divided by 12% of this 20% of 12 rupees. Now it comes to 1200 units per order. So EOQ is 1200 units. Next problem. A manufacturer buys certain components from suppliers at rupees 30 per unit. Total annual needs are 800 units. The following further data are available. Annual return on investment 10%. Rent, insurance, taxes per unit per year is 1 rupee. Cost of placing an order is rupees 100. Determine the economic ordering quantity. So cost of carrying inventory per unit is 30 rupees into 10% plus 1 rupee. That is the rent, insurance and taxes. We'll get 4 rupees. So EOQ will be square root of 2 into 800 into 100 divided by 4. So to 800 is your annual need into the ordering cost is 100 divided by 4 rupees is carrying cost. I'll get 200 units. Now we will pass on to the next problem. An automobile unit purchases 8000 units of a fast consuming item per year and as per the current policy procures this item every quarterly. Comment whether the existing policy is optimal in the background of the following data. Cost per order is 250 rupees. Unit cost of the item is 25 rupees. Inventory carrying cost is 25% of the item of the value per year. In your opinion, if this is not the optimal policy, what other policy would you suggest? Quantify the benefits, if any, in terms of money. EOQ is equal to square root of 2 into 8000 into 250 divided by 25% of 25 rupees. We'll get 800 units. The existing policy of purchasing 3000 units per quarter is not optimal. Now the cost of the purchase under the existing policy is ordering cost is 4 into 250, that will comes to 1000. Inventory carrying cost is 3000 into 25 and divided by 25%, it is 18750, that comes to 19750. The cost under the new policy, ordering cost is 12,000 by 800 into 250, we will get 3,750. Carrying cost is 800 into 25 divided by 25%, we will get 5,000. So we will get 8,750. The benefit that is derived in terms of money is 19,750 minus 8,750. 11,000 is the benefit derived because of this new policy. The next problem. A firm expects sales of 90,000 units that cost the firm rupees 5 per unit. It has a policy of having 20 days as a safety stock level and has estimated that the carrying cost or 20% of the inventory value. Order cost of rupees 25 and the lead time is 20 days. What is the reorder point for the firm and how many units should the firm order? Reorder point is equal to 90,000 units divided by 360 days into 10 plus 20, that is 20 days is for the safety stock and the lead time is 20 days. Reorder point is equal to the month during the lead time plus the safety stock. Economic ordering quantity is a calculation used to determine how much to order, but reorder point is said to be a metric mainly to calculate the time then at which the order has to be made. This is to avoid your stockouts and to forecast the demand. Now the reorder point for the firm here is 90,000 divided by 360 days, that is your average sales, into 20 days safety stock plus the lead time 20 days comes to 10,000 units. So when it comes to 10,000 units, the next order has to be placed. EOQ is 2 into 90,000 into 25 divided by 20% of 5 rupees, and thus we have to find out the square root. So it comes to 2,121 units. So reorder point is 10,000 units and EOQ is 2,121 units. Welcome learners. I am Dr. Amuda from School of Management, Shastra University. In this session, we shall see about the problems in economic batch quantity. Economic batch quantity is equal to square root of 2 into annual usage in units into setup cost divided by cost of carrying 1 unit in inventory for 1 year. Now we shall pass on to the problem. Mrs. Kobo Bearing Company Limited is committed to supply 24,000 bearings per annum to Messrs. Deluxe Fans on a steady daily basis. It is estimated that it costs 10 points as inventory holding cost per bearing per month and setup cost per run of bearing manufacture of rupees 324. What should be the optimum run size for bearing manufacture and what should be the interval between 2 consecutive optimum runs? Find out the minimum inventory holding cost. So this company is committed to supply 24,000 bearings per annum and cost of holding per bearing per month is 10 paise and cost per run setup cost is 324. Now we shall apply it in the formula. EBQ, economic batch quantity, is equal to square root of 2 into annual usage. What is the annual usage? 24,000. It is given in the problem. Into setup cost. Setup cost is directly given in the problem as 324 divided by the carrying cost. So 12 rupees into 10 paise. That is the cost of carrying 1 unit for 1 year. So 1 rupee 20 paise. Now we have to apply it in the formula. We will get 3,600 units. Optimum run size is 3,600 units. Now we will find out the interval between 2 consecutive optimum runs. 24,000 bearings per annum, that is 2,000 bearings per month of 25 working days. Hence, 3,600 units, that is the EBQ, divided by 2,000 bearings per month into 25. We will get 45 working days interval between 2 consecutive optimum runs. I will repeat again. 3,600 is the optimum run size. 2,000 is said to be bearings per month and 25 working days. So 3,600 divided by 2,000 into 25 will get 45 working days interval between 2 consecutive optimum runs. So 3,600 divided by 2,000 into 30 days will get 54 calendar days. If it is taken for a full month, so it will be 54 calendar days. So calendar days is different from working days. Working days is the number of days that has been actually worked. So as far as the working days are concerned, we will get 45. In case of calendar days, we will get 54 days. Average inventory is 3,600 divided by 2, we get 1,800 bearings. So minimum inventory holding cost per month is 1,800 into 10 paise into 12 will get 2,160. That is the minimum inventory holding cost per month. We shall pass on to the next formula. Next problem. A positive molding fork produces and uses 24,000 Teflon bearing inserts annually. The cost of setting up of production is Rs 85 and the weekly production rate is 1000 units. If the production cost is Rs 5.50 per unit and the annual storage and carrying cost is 50 pice per unit, how many units should the firm produce during each production run? Once again, we have to apply to the formula. We will get 85 rupees is the setting up cost, 24,000 Teflon bearing inserts it is annually. So 2 into 85 into 24,000 divided by carrying cost is 55 per unit. So 1 minus 24,000 by 52,000, that will be the denominator. We will get 3,893 units. That is the Teflon bearing inserts. 3,893. Pass on to the next problem. A product is manufactured on a machine. The cost of production, the demand, etc. are given below. Fixed cost per unit is 30 rupees. Variable cost per unit is 10 pice. Percentage of charges for interest, taxes, insurance, storage, etc. is 50%. Then production rate is 1 lakh units per year. Demand rate is 10,000 units per year. Determine the economic lot size. Now, economic lot size ELS is equal to square root of 2 into demand rate into fixed cost per lot. So 2 into demand rate is 10,000 units. If the fixed cost is 30 rupees, divided by variable cost into 1 minus demand rate percentage of production rate divided by production rate. So 2 into 10,000 divided into 30 divided by 10 paise into 50 paise into 1 minus 10,000 divided by 1 lakh. So we have to find out the square root. We will find it as 3,651 units. The demand for an item is uniform at a rate of 25 units per month. The fixed cost is 30 rupees each time a production is made. The production cost is 2 per unit and the inventory carrying cost is 55 per unit per month. If the average cost is 3 pice per unit per month, determine how often to make a production run and of what size. So optimal order quantity will be square root of 2 into 25 into 30. 25 is the units per month, fixed cost is 30, divided by 50 paise, that is the carrying cost, into 50 paise is the carrying cost and 3 paise is said to be the average cost, divided by 0.3, that is the average cost, we will get 90 units. If 90 units is the optimal ordering quantity, divided by 25, it will be 3.6 months. That is the optimum scheduling period between 2 consecutive runs. Pass on to the next problem. The probability distribution of annual demand for cycles is given below. We will have a demand of 3,000, 5,000, 10,000 and 15,000. Probability is 0.1, 0.3, 0.5, 0.1. What is the economic manufacturing lot size? If the setup cost is Rs 1000 per setup and carrying cost is Rs 10 per cycle per year. Now we have to find out the mean demand. Multiply the probability with the demand. 3000 into 0.1 plus 5000 into 0.3 plus 10,000 into 0.5 plus 15,000 into 0.1. So you get 8,300. Now economic batch sizes 2 into 8,300 into 1000 rupees as setup cost divided by carrying cost is 10 rupees. So you get 1289 units as the economic batch size.